Welcome. In this video, we're going to talk about regular expressions. There are two alternate methods besides DFAs and NFAs to describe regular languages. One is regular expressions and the other one is regular grammars. In this video, we're going to talk about regular expressions. Regular expressions are very similar to arithmetic expressions, and they may be convenient in a way to describe a language due to their simple string form. Rather than creating a DFA or NFA, you can describe a language using a regular expression. Just to remind you that the definition of a regular language is that there exists a finite acceptor for it. In other words, there exists a DFA or an NFA that accepts the regular language, and that's what our definition of regular language is. So there's another way that you can describe regular languages, and that's by using regular expressions. So in this video, I'm going to demonstrate how to do that. So regular expression, the notation, it involves a combination of symbols from the alphabet, whatever the alphabet is. We've been using alphabets 1 and 0 and A and B, but the alphabet could be any symbols. And then you use parentheses and you use some operations. So let's define what all of these primitives are that you can use to formulate your regular expressions. All right, so you can use, these are the primitive regular expressions, the empty string, the empty set, and then any symbols that are part of your alphabet. You can also use parentheses and the plus operator, which is for union, the dot or concatenation operator, and the star operator. So here is, if two languages are regular, then you can use the plus for union, the dot for concatenation, you can have star closure, and you can also use parentheses. So if R1 and R2 are regular expressions, you can, of course, we already said that regular languages are closed under certain operations, and these are also then regular expressions. It's going to be much more clear when I show you examples. Okay, so just to read this, a string is a regular expression if it can be derived from primitive expressions and a finite number of applications of the operators above. So we're going to use the primitive expressions and the operators to formulate regular expressions into a string. So the language of a regular expression is defined by the following rules. You have the language of R, so if you assume that R1 and R2 are regular expressions, then you can have the empty set, of course, and you can have the empty string, which is not the same thing as the empty set, and you can have any symbol in the alphabet for your regular expression. And then just to show you what union, how union works, if you have regular expression 1 or regular expression 2, that would be the language of regular expression 1 union with the language of regular expression 2. You can have the regular expression 1 concatenated with the regular expression 2, which would be the language of regular expression 1 concatenated with the language of regular expression 2. You have a regular expression in parentheses, then that denotes the language of that regular expression. And then, of course, you can have a star closure of a regular expression, and that means any combination. All right, I think it's much better to understand by looking at examples. So we have here an example of a regular expression. So we're using parentheses and we're using the star operators here. So if you take a look at this, you can see what does this language, what is this regular expression, what language is it defining? So you must have an A, B, star. So if you have a star, that means it would also include the empty string. So the language right here would be any either the empty string or any string with AB. So some strings that would not be in this language would be a single A, a single B, ABA, but some strings that would be in the language would be the empty string, AB, ABAB, ABAB, etc. So this is the way that we put it in our notation before, AB to the n, where n is greater than or equal to 0. So that could be AB to the 0, which means there is, that's the empty string, but it would also include any strings with AB. All right, here's the next regular expression. Here's a regular expression. So this says A or B. That's so what would the language be? A or B. So this is a very simple finite language that is A or B. So this does not include the empty string. The language is the symbol A or the symbol B. And here is another one, A or B with the star, using parentheses. So what language is this describing? So does it include the empty string? Yes, it does, because it means that you could have, using the star, it means that you could have nothing, you could have to the 0, or you could have A or B. So this is any string formed with A or B. All right, so let's take a look at this. This regular expression, A, and then in parentheses you have BB with a star. So does this language include the empty string? No, it does not, because you have to have at least an A, and then you could be followed by any number of BB. So this is, it must begin with an A, and then it can have any number of BBs. So A is in the language, ABB, A, BB, BB, etc. The next one, does this include the empty string? No, it does not, because it must end with an A or a B. So you could have any number of A's, and then the string must end with either an A or a B. So any number of A's, including 0 A's, followed by an A or a B. All right, this is any number of AA's, followed by any number of BB's, and followed by a B. So this string must end with a B. It has at least a B in it because the B does not have a star next to it. So the empty string is not part of this language. So this is an even number of A's followed by an odd number of B's. Right? So an even number of A's could be 0 A's and then 1 B, or it could be a bunch of A's as long as it's an even number of A's, and then an even number of B's, and then 1 B, which would make that an odd number of B's. All right, so let's look at another example. So let's try to decide what this is. You could have a 0 or a 1, followed by 2 zeros, followed by any combination of zeros or ones. So basically, this is saying that your string must include a double 0 somewhere in it. So it must include at least one pair of consecutive zeros.